Time value of money tables make the majority of calculations relatively easy, and there are 5 primary time value of money tables. They are the future value of $1, the present value of $1, the future value of an annuity of $1, the present value of an annuity of $1, and amortization or payment schedule. So let's say that you receive $1,000 at your college graduation. If you invest the gift and earn 8% annually, how much will you have in 20 years? Well, remember the future value is equal to the present value times 1 plus the interest rate raised to the number of compounding periods. And so if our present value is $1,000, then we're going to multiply that $1,000 times 1 plus 0.08, and we're going to raise it to the 20th power because we're going to save this $1,000 for 20 years. And as a result, we will get a future value of $4,660.96. Now, if we wanted to solve this problem using the future value table, what we would do is first find the number of periods, which is 20, in the first column of our future value table. Then we would move to the right until we find the future value factor that corresponds to the 8% column. And that factor is going to be 4.66096. Next, we multiply this factor by our present value of $1,000. So again, $1,000 times 4.66096 is equal to $4,660.96. Now, what if we're offered the choice of taking $1,000 today or $1,200 in 5 years? How do we know which offer is better? Well, let's say we could earn 5%. Well, the present value is equal to the future value divided by 1 plus the interest rate raised to the number of compounding periods. So that would mean that $1,200 in the future divided by 1 plus 5% raised to the 5th power should be equal to our present value, which comes out to $940.23. So that means that $1,200 in the future is worth $940.23 today. So if we're offered the choice of taking $1,000 today or $1,200 in 5 years, that $1,000 today is actually a better deal because it's greater than the present value of $1,200 5 years from now at 5% interest. So to use the present value table, we would find the number of periods in column 1, which again was 5, go to the right until we find the present value factor in the 5% column, and that's 0.78353. And then we would just multiply the $1,200 that we would get in 5 years times that present value factor of 0.78353, and that would give us $940.24. How much would you accumulate in 20 years if you start saving $1,000 every year and earn 9% on your savings? Well, the future value of an annuity is equal to the payment times 1 plus the interest rate raised to the number of periods minus 1, and then all of this is divided by the interest rate. And so if we multiply this all out, we'd have 1,000 divided by 0.19 times 1 plus 0.09 raised to the 20 minus 1. And we would end up with $51,160.11. But if we use the future value of annuity table, we would first find the number of payments, which is 20, in the first column. Then we would go to the right until we find the future value factor corresponding to the 9% column, and that would be 51.16012. And then we would just multiply that by $1,000, and that would give us that future value of $51,160.12. Now imagine that you have just received a sizable inheritance with the following choice. One, you could take a lump sum of $1 million today, or two, you could receive $75,000 per year for the next 20 years. And the interest rate would be 5%. So if we use the present value of an annuity formula, we would find that 75,000 divided by 0.05 times 1 minus 1 over 1 plus 0.05 raised to the 20th power would give us the present value of an annuity of $934,665. If we use the present value of an annuity table, we would find the number of payments, which is 20, in the first column, and then go to the right until we find the present value factor that corresponds to the 5% interest column, and that's going to be 12.46221. We would multiply 75,000 by 12.46221 to get $934,666. Now there are times where you'll need to calculate what's called an amortized payment. This is a payment of the same amount for a set number of months or years, such as for a car loan or a mortgage. So to do so, you should use the formula that says the monthly payment is equal to the present value times 1 plus the interest rate raised to the n over 1 plus the interest rate raised to the n minus 1. So let's say that Max wants to borrow $250,000 to purchase a home. He can get a 30-year loan at a 6% interest rate. To help Max determine if he can afford this loan, you first need to convert the years to months and the yearly rate of interest to monthly interest because Max will be making monthly payments. So our number of periods then is going to be 360, or 30 times 12, 30 years, 12 months per year. And then our monthly interest rate is going to be 6% divided by 12, which is 0.5%. So if we use the amortization table, we would find the interest rate of the loan in the first column, and then we go to the right until we find the amortization factor that matches 30 years, and that's going to be $6. So then we divide the loan amount by $1,000. So we take $250,000 divided by $1,000 and we get $250. So now we multiply $250 by $6 to get approximately $1,500 as our payment.